Alright girls, so we're going to finish up this problem from today's class. I'll go through it and you'll be watching this from home, and hopefully you're starting to understand the process well enough now that you can anticipate what I'm going to do before I do it. So we talked about this step as the bell was ringing. Erin had suggested that we take row 2 and row 4 and subtract 2 times row 1 from that. But as I was pointing out in class, we want to get a 0 here. And if we take row 3 minus 2 times row 1, they're going to wind up with a negative 2 down here in this spot, but we want this to stay a 0. So in order to prevent getting something non-zero in this place, we're going to take row 3, and we'll add row 4 times row 2 to it. Let's try that again. Row 3 plus 4 times row 2. And I have that written down here at the bottom. Alright, so let's do it and see what happens. Row 3 plus 4 times row 2. If I take row 3 plus 4 times row 2, I'm going to get a 0 still in this first spot. Negative 4 plus 4 times 1 gives me a 0 in the second slot here. And then I've got 7 over here plus 4 times negative 1. So 7 minus 4, that gives me 3 here. And in the last spot, I've got 11 plus 4 times negative 2. So 11 minus 8, that gives me 3 over here. Now, as I was saying in class, we'd like to get 1s all along this main diagonal. And we'd like to have 0s in this area. And we're really close. Look, we've got 0s down here. And I've got a 1 here, a 1 here. I need a 1 down here. And a really easy way to get there is to take this row 3 and divide by 3. So I'm going to pause the recording for a second while I transfer everything over, and then I'll pick it back up in just a second. Alright, so I've done the operation you see over in the bottom right hand corner 3 here. I've got R3 divided by 3. So now we have 1s on the main diagonal and 0s below that, which is perfect because remember that this matrix really just represents a system of equations. And so what I'm going to do now is we'll take the matrix that we have and we'll translate it back into equations. So here we go. First row, I've got a coefficient of 1 for x right here, so I'll just write that as x, and then negative 2 for y, minus 2y, and 3 for z, so plus 3z. This bar represents our equal signs, and then I've got a 7 over here, so this first equation is equal to 7. I'll do the same thing for the second one. I've got a 0 here for x, so I don't even need to write that. I've got a 1 for y, so y, and then a negative 1 for z, minus 1z, or just minus z, equals negative 2. And then in the last row, I've got 0 for x, 0 for y, and I've got just a coefficient of 1 here for z. So z equals 1. That's our last equation. Look how nice this is. Now I've got a system of equations where I know already the value of one of the variables. And all I need to do is take that z equals 1 and back substitute it into this equation, the second one, and solve for y, and then once I have y and z, I back substitute into the first one and find out the value for x. So let's do it. Z equals 1. I'll just put that over here, kind of out of the way. Z equals 1. I know from the second equation that y minus z equals negative 2. Y minus z equals negative 2. So y minus, whoops, not equals, that should be a minus sign. Y minus 1 equals negative 2, which means that y equals negative 1. And then x from the first equation, I know that x minus 2y plus 3z equals 7. Let me rewrite that. I need some more room here. Excuse me. X minus 2y, but I know y equals negative 1, so let's put that in, plus 3z, but z is just equal to 1, so that's 3, equals 7. So x plus 2 plus 3 equals 7, x plus 5 equals 7, x equals 2. So I've now solved this system using the method of elimination, or sometimes called linear combinations. We're using row operations. And I'm just going to list the solution as an ordered triple. So x equals 2, y equals negative 1, and z equals 1. So we list the solution like this: 2, negative 1, 1. And then, of course, we need to go back to the original system and make sure that this ordered triple satisfies all of our original equations. So 2, negative 1, 1. Let's go back to the original system here. It's in this top left corner. And we need to make sure the solution satisfies that all three of the equations here. So if x is equal to 2, I've got 1 times 2, that gives me 2, minus 2 times negative 1, and then plus 3 times 1, and that does in fact give me 7. Second equation here, I've got 2 times 2, plus 1 times negative 1, plus 1 times 1, and that does equal 4, so this one checks. And then the last equation, I got negative 3 times 2, plus 2 times negative 1, plus negative 2 times 1, and that does equal negative 10. So the solution is valid. That ordered triple solves all three of the original equations. So it's a solution to the system. All right, I will, or I did, along with this video, post some homework on Homework Now. So I want you to go ahead and work on those problems, and we'll go over them in class tomorrow. Good luck. Look back over the video if you get stuck, or you can send me an email and I'll help you out. See you tomorrow.